Hello, today we're going to look at the second type of formulas that are presented in section 5.5, and those are the power reducing formulas. Now the power reducing formulas help us to rewrite expressions that have higher powers like squares or fourth degrees or sixth degrees into smaller powers, and preferably in terms of just sine, cosine, and tangent. So the first one we're going to look at is sine squared of u. Now, if we have sine squared of u and we want to rewrite it in terms of an expression that does not have a square in it, it becomes 1 minus cosine of 2u over 2. Now that might look a little bit strange because we're taking a sine squared and changing it into a cosine, but these formulas actually come straight from the double angle formulas that we just looked at. So let's start by looking at where this one comes from. If I take a look at cosine of 2u from the double angle formulas, there were several ways we could write that. One of those ways was to write it as 1 minus 2 sine squared u. So we're going to take this formula, which we've already proved to be true, and we're going to solve it for sine squared of u. So to do that, I bring the 1 over. So we get cosine of 2u minus 1 is equal to negative 2 sine squared u. Now let's divide both sides by negative 2, and we get cosine of 2u minus 1 over negative 2 is equal to sine squared of u. Now the problem is that's not exactly what the formula states that I've written over here. We don't have a negative in the denominator. So let's bring that negative up to the top. When I do that, it's going to change the signs on both of these terms in the numerator. So that's going to give me the opposite of cosine of 2u plus 1 over 2 is equal to sine squared of u. And now all I need to do is switch these two around and I'll have the new formula. 1 minus cosine of 2u over 2 is equal to sine squared of u. So that's where this particular power reducing formula comes from. Now I bet you can guess the next one we're going to look at. The second one is cosine squared of u. And cosine squared of u is going to look rather similar to the sine squared u, but it's actually 1 plus cosine 2u over 2. Now again, this one does come from one of our double angle formulas, and again it comes from cosine of 2u. But this time I'm going to let cosine of 2u equal 2 cosine squared u minus 1, because again I'm looking for what is cosine squared of u. So as we did with the last one, let's go ahead and solve this and isolate cosine squared of u. So we're going to add 1 to both sides. So that's going to give me cosine 2u plus 1 is equal to 2 cosine squared u. Now divide both sides by 2, and I end up with cosine 2u plus 1 over 2 is equal to cosine squared u. And again, the only difference now is these two are switched around when I wrote the formula down. But again, addition is commutative, so that is not a problem. So I get 1 plus cosine of 2u over 2 is equal to cosine squared of u. Okay, let's take a look at our third formula, which is tangent squared of u. And this one's going to look a little bit familiar to what we've already done. It's actually equal to 1 minus cosine of 2u over 1 plus cosine of 2u. I bet some of you can see the relationship there exists between these three expressions right now. If I go back and look at sine squared u, look, there's the 1 minus cosine 2u. Cosine squared has 1 plus cosine 2u, and tangent has a combination of those two. And that's because we do use the previous two in order to prove this one. So if I were to take tangent squared of u and write it as sine squared u over cosine squared u, again, that's something you're familiar with, the quotient identity. I can actually substitute in what we've already done for sine squared u, which is 1 minus cosine of 2u over 2, and put that all over our cosine squared u, which was 1 plus cosine 2u over 2. Now, when you have a complex fraction like this that happens to have the same denominator in the top fraction and the bottom fraction, the simple way to reduce this is to cancel those same denominators. And notice when we do that, we do end up with 1 minus cosine of 2u over 1 plus cosine of 2u, which is our power reducing formula for tangent. Now, these formulas are actually very important in calculus. There are many times in calculus where we will want to take a power and rewrite it in simpler terms. So let's take a look at an example and show you how you might end up using this. So the example that I want to take a look at is the following. We want to rewrite as first powers of cosines. Okay, so what we're going to take a look at is cosine to the 4th power of x. And we want to try to rewrite it. Now, it's a little bit larger than the formulas we just looked at, but we can actually use our formulas to rewrite this. The first thing I'm going to do here is rewrite cosine to the 4th of x as cosine squared of x squared. There are 2 of them there. Next, I can use my power reducing formula here to rewrite the inner cosine squared of x here. That's going to become 1 plus cosine, and again you take 2 of the angle, so we have 2x over 2 quantity squared. Now we're going to need to do some algebra. There will be quite a bit of algebra in this problem, in fact. We need to square this. So to square it, I need to square the top, and remember you're foiling here. This becomes 1 plus 2 cosine of 2x plus cosine squared of 2x all over, and I also need to square the 2 in the denominator, so it's all over 4. Now, I'm going to move this 4 out to the front here. Sometimes that makes it a little bit easier to work with the problem. So if I rewrite this as 1/4 times the numerator, it's the same thing. And I get 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay, now we've gotten part way there, and now I no longer have a cosine to the 4th, but notice that I still have a cosine squared right here. So I need to apply the power reducing formula once more. So this is going to become 1/4 times 1 plus 2 cosine of 2x, that doesn't change any, plus, and now I need to rewrite that using the power reducing formula. So this is going to become 1 plus cosine, Now remember, it's 2 times whatever angle I started with. And so if you look carefully here, what I'm starting with is my 2x. So if I take 2 of those, that's what I need to put into my formula here. So I have 2 times 2x, which gives me a 4x all over 2. Okay, and remember that's still in the parentheses. Now, this might be looking a little bit nasty with all the fractions in here, so it might be easier now to distribute that fraction back through and see what I come up with. So this becomes 1/4 plus, and 1/4 times 2 is 1/2 cosine 2x, plus, now this is 1/2, so 1/2 times 1/4 gives me 1/8, plus cosine of 4x over 8. All right, so I've got all kinds of fractions in here, and at this point I can look at my expression and see that I've got cosine here, I've got cosine here, there are no more powers in here, but there is one more thing I can do. I do have a 1/4 and a 1/8 that I can simplify down, and I don't want to finish this problem until I do that. So that becomes then 3/8 plus 1/2 cosine of 2x plus 1/8, I'm going to pull that out and write it as 1/8 cosine of 4x. And I could be done at this point. Now sometimes in calculus you'll want to also factor out those fractions, and so we may want to do that again at this point. So if I were to do that, I actually would only factor out a 1/8 to get rid of the denominator. That would be my common denominator of all 3 terms. So when I factor out the 1/8, I'm left with a 3 plus, now if I factor an 1/8 out of a 1/2, what am I left with there? Well, in terms of eighths, this would have been 4/8. So I'm actually left with 4 cosine of 2x plus a cosine of 4x. And there would be another way that you might see it written in calculus. So lots of algebra in this problem. And again, there's a couple of steps I used here that you may choose not to use. Remember in this step here, I factored out my 1/4, and then I decided to multiply it back through again, and then I factored it out again. You might just want to wait and factor it till the very end. The reason I factored it was I didn't want to have fractions within fractions as I went into these steps right here. So there are different ways that you can do your algebra here, but in the end you may want to write it either like this or like this, depending on the work you're going to end up doing with it. So that ends our lesson on power reducing formulas. Good luck with the assignment.